Okay, so today we are going to start to talk about monads. It's a pretty, a powerful concept that we hope we start learning. There are a bunch of definitions, pretty formal, but the idea is just use the practical way. So let me share my screen. Can you see screen now?
Yes.
Cool. Increase our font. Okay, the idea is just start checking the abstraction of monad. So in a pretty informal definition, that's the idea. Start using that. The monad is an abstraction that we always implement flat map operation. So the idea with flat map is just give an operation, give an monad, and make any operation and returns at the same context or the same monad. That's the idea. We have two operations defined under monads. It's definition pure. It's just say in pre-informal words, add a context for any value that we need. It's pretty simple, but it's powerful at the same time. The flat map is just try to compose and return the same context all the time. This is just the implementation for the type class style for monad. It's just an wrapper for flat map operations. Nothing new here. So let's move to an example. So we have I create an ID definition. It's just an wrapper for any value. So the idea is just implement for that ID. Cool. The idea is here's the implementation. Just the pure function as I mentioned it, just add the context that we want. On the flat map, just enter a value and return the same context. Not much for this. Let's create an object sample to show what kind of things we can do. This is just for make it runnable. But the idea is I'm gonna create an ID. Let's do it. We can do this, remember, using the magic of type classes. Now and also we need this import. Now we have an appear ID. This type should be an ID for int. Let's see. And yeah, this is the first example. We have a generic value or primitive value, and we include a monadic or a monad as a wrapper. Monad it's not a wrapper. Be careful. I saw many post on internet saying that's just on a grapper, but it's a little bit different. So let's do this. So our idea is just introduce and a kind of combine these computations always within ID definition that we provide. That's just for an example. Could be in a real world, could be really more interesting than this. We have two options for flatmap, is, or if you prefer symbols, could be also. I prefer this flatmap. Here within a flatmap, we will have the real value. Let's say to make it easier to read. And you know, we could do this just +1. So as we can see, we nothing special at the moment, just the idea for start to introduce other computation. This is the general idea, it's just for demonstrative stuff. Probably in the real world, we will have to better things or pretty nice things to start doing. So at the moment, you have any question about the concept?
Yeah, monad in other okay, a monad in another language, for example, how would you declare that in, let's say, JavaScript or TypeScript? Because I don't understand how this is different from example.
So can I take like just 2 minutes here and maybe help people, because I've seen a lot of frustration, especially in the last session, explaining the functors. So don't worry, Giovanni, I'm gonna take this out of the recording. But I just want to share a little bit my journey. You know, learned functional programming, and I used to code in F#, which is a functional language on the .NET runtime. So I know most of you have more experience in object orientation. So let me kind of draw some analogies and maybe help kind of clarify why this looks so different yet familiar and almost looks redundant. So it's all about, so the two paradigms, functional or object-oriented, it's all about hiding information. It's all about encapsulation, right? So we implement an object-oriented programming in a certain way. We have some techniques for that. But in functional programming, it's all about containers, right? So it's all about putting value inside containers and having idempotent operations on them, mainly mapping and reducing or folding. So functor is one sort of container. You can look at the monad as another sort of container that allows certain operations, idempotent operations. The purpose of all these containers is to prevent side effects in functional programming. So maybe just you take a step back and maybe on the side, what I would recommend is read a little bit about type algebra, because as you can see, Giovanni is what he's giving us is basically types and operation on types, right? So, and this is very, very category theory, basically, is the closest thing that all of these concepts come from category theory. So mathematicians developed functional languages because they were looking at lambda calculus, they were looking at category theory. And for them, you know, they give you definitions of monads about like kind of a general identity function over a category and whatnot, like something that might seem esoteric, but it's all based in that. So I would say don't be frustrated. Just think of what we're looking at as like just containers, and you're doing side effect free operations on the values inside the containers. Yeah, and maybe read a little bit on category theory. It'll help you like embrace this a little bit more. So just wanted to share my 2 cents on this. Don't get too frustrated. Don't get too hung up, and don't get on drawing analogies with other languages. So for instance, we all know a monad in C#. Of those of you who wrote C#, it's called select many. Select many in C# is a monad because it has a flat map operation on an IEnumerable, right? We all know functors in JavaScript. Any list in Python or JavaScript in a basic way is a functor type, right? Because it gives you the map function. So just take your time and don't be too frustrated. And I think Giovanni is doing really a good job. But some of the concepts are just basically too new for people who have not, done functional programming again. So anyway, I'm going to shut up right now. Just hopefully this helps a little bit orient or alleviate some of the frustration, and we can go back to the recording.
Cool. Yeah, in general terms, that's the idea. Just remember, as functional stuff, you will need a kind of be handy to make computations or make combinations. I mean, things like that. So if you provide an wrapper, this kind of combinations start doing a little bit easier than doing in other styles, because you have the context. The context. So see this as a box, and you extract the content on the box and do any operation and put in the box again, just to make sure in the whole program you will be able to combine or I'm not I forgot the idea that I was thinking, that
or map, combine or map.
Exactly, combine or
Chain.
substitute
Chain.
is the move.
Chain.
Okay,
Yes.
change could be better. Yeah. So let's try to understand a little bit more the cases that where we could use monads. So just for null label problem. So in our common or imperative stuff, we probably will have something like this. See this on a stream, but for any reason we do this. So to deal with that absence of this value, we probably will have to do something like this. Here we do some stuff, and probably this is a pretty common stuff that we use for null labels, just checking the value and do anything if we already are sure that we have the value. In other case, probably we throw an error or do anything. That's the common. This is pretty difficult to maintain for testing also. You can see this piece of code deterministic. That means it's not pure. That's the problem. So we have almost in Scala, we have on a monad optional.
So, and just here note so that people understand why this is not pure. It's not pure because we have a side effect on line 33. So we're throwing an exception.
Exactly.
So
we can determine, we can associate all the inputs or all the input value with one answer. That's the idea. We have something in the middle that makes this difficult. So we have in Scala this definition. It's an optional value, and this is an ADT implementation. If you remember, just we have an OR pattern for abstract data type, one for sum that we already have. We have the value, and none that means we don't have. That's the idea. So in a real world, probably we could start do something like this. I'm gonna write this just for be easier our code readable. Just want to extract the value for my optional and do other operation. This just remember just for if an idea, the idea is do examples, per example, to pretty simple, or give you the knowledge required. But remember, this could be any computation that you want. So the type for this is would be an optional string, and we start to concatenate these computations. So this could be, call an API or save on the database, whatever you want. The idea is just start to do anything with the response and combine with the other computation and things like that. So here we have this as an answer. So right now, just to show you something pretty important, let's see that piece of code. We start doing something, in any part of the program, we get an unknown definition. The type doesn't change. So, but the answer, the value for the program is not. That means this is a pretty way to check this. I know we lost some information. We would like to know why this would be this is none, but this is another we have another monad to deal with that. So this is the idea. Generally, you have on a sequence of computations, and you start doing something for this. So if in any computation concatenation you get the known or the annulator operation, you will get whole operation will be annulated, which is pretty nice because we wrote less code, and we can start to testing this independently. Remember, it's pretty powerful when you start thinking in that way. So, but what about we have information about why it's failing, because none is really not nice to understand what's happening with our program. We have an either right, probably you will find in the literature as disjunction, but the idea is just have two projections our computation. This is pretty useful. I'm gonna use simple types just to and do the examples complicated. So the idea is the same as optional, or almost pretty similar. We have two objects or two definitions for either we have on a right value or on a left value. The idea is instead of just manage null labels, we are gonna use this right computation. That means the program was successful, and in case that it fails, have extra information that what's happening. So any question up to this moment?
I think I got a comparison with this to Rust. Rust has something similar when there's a possibility that a value can be one of many. It has a similar switch case system where you must choose a value for every single possibility for that value. Which is more or less like a Schrodinger's cat box.
Exactly. Yeah, I think it's pretty similar. I think Rust is functional based also. But yeah, the idea is to start thinking in what things we have to do instead of how. You know, this is pretty readable program. Just start doing things and concatenate, and that's it. We don't have to take care about this. The compiler will do for us, which is nice. Less things that we have to keep in mind, less effort. I know in short time could not, because we know already other things, but long term it's easier start to thinking that way, even for create pretty nice scenarios for testing. So we have we'll have other computation. We just say nothing special here. We got the computation successful, but we can do this. This is a wheel card just for saying doesn't matter the result, just do the operation. It's to model unit. failed. So now we have the left projection, but now we have a little bit more information about that, which is pretty useful to start to debugging. You just could start checking the logs and see what's happening. This improve our ways to catch errors or things like that. Probably strings is not a good type. You could be more creative here, create a class error and start typing errors. But at the moment, it's okay. So this is the idea. When we want to manage the behavior of our programs, probably either could be nice to use. So in case that we got any exception or anything that we don't expect, just we use the left projection to say whole program, okay, I'm failed, but this is the reason. If you see, we don't have any throw exception in our program, which is nice because the program will continue running without failures or controlled failures. That is the thing that I mean. So questions or things that you need, I try to clarify for you.
The final thing there, the yield C2 in line 59, that means that C2 is the default answer.
The result.
The default result.
Yeah, this is same. So we could do this. Now it's a little bit more complicated to read. This is the result. But this stuff could be pretty unreadable. The idea is just do our code less verbose as possible. This is equivalent to this. That's the idea.
Giovanni, in the case that either is a list, just a value.
You mean this?
Yes, yes. In this case, the for loop when there is a left value for some element will interrupt the whole for.
This is not a for loop. It's just pattern matching. So just be careful. You're not iterating here.
Oh, yeah, sorry. So in the case of a list, if you want to process the value.
This is a sequence of computations, not an interruption or this. Yeah.
Okay.
Get, in this
so you
case,
have to process the good list in the.
Hold the list instead of
okay.
any element.
Okay. Perfect. Thanks.
But yeah, this is a pretty interesting stuff because probably we will have. So imagine that this is an error. This is an model that we are using for calling an API. On the left, the errors, but probably we'll have on a list of results. Could be useful in a real scenario. There are an alternative to use that because we could start to start. We could try to use this. Also, the list in Scala has the flat map implementation. Could be treated as a monad in this case. But we will have to start doing, for instance, here. Could be pretty difficult to start to do things with the elements. Difficult to read. So there is another monad transformer to do that kind of things. Probably in the real scenarios, I see this on a asynchronous monad, and within then we have other monad. But let's we'll see this in our next session. There are a bunch of previous full monads. I will try to use the most common, and the others I will put in our exercises just for you try to do the implementation by yourself. But yeah, to grasp all the context, the concept. But yeah, we'll see this soon.
Okay, thanks.
I think we can stop here, and the next session we'll see monad transformers and probably an asynchronous stuff for this, or how to manage side effects in a nice way. I will try to explain you in the next session. Any other question? No. Okay, great. So that's all that I have for now. I hope you start enjoying that stuff, and yeah, let me know if you have any question or any other thing that you want to talk about a little bit more.
Thank you, John.
Yeah, for sure.
Yeah, sure.
Hey guys, thanks for coming.
Thank you, Giovanni.
Thank you. Thanks for the clarification, Anas.
No problem. Hopefully that helped, because a lot of the concepts, you need to remember that we're talking about completely different paradigm. It's all about purity and idempotency and managing side effects, and it's just the paradigm shift is difficult. Not the syntax per se. So it's gonna get a little using to, but you know that's the fun part, right? I think now your brains are hurting a little bit, but it's one of the most interesting workshop, because I mean, especially you, David, like you've coded in Java for the longest time, and before Java became mixed paradigm with Java 8 and beyond, I mean, it was all imperative object oriented, and now you're seeing kind of function combinations and running computations, things of the sort. So anyway, do not get discouraged, and keep fighting the good fight. Thank you, Giovanni, and we'll see you next session.
Sure, anytime.
Sure. Right. Thank you. Bye-bye.
Bye-bye.